Right, for the final example of elimination, substitute solving of simultaneous equations, we're looking at where we're going to actually have to change both equations so that they have the same pronumeral. In this instance, we're going to be looking at the lowest common multiple, essentially, of both equations. So if we look at this 3 and 5, the lowest common multiple for 3 and 5 is 15. The lowest common multiple for 2 and 3 is 6. So we're actually going to go with changing the y coefficients to make them match and leave the other ones as they come out based on that. So we've got equation 1 and equation 2. Now, our instructions in this one are actually going to be twofold. So we're going to, first off, okay, so the first thing we're going to do is we are going to multiply, or an easier way of writing this is actually to just say equation 1 times 3 and equation 2 times 2. So we end up with two new equations that are essentially the same, they'll just have different pronumerals. So ensuring that we multiply all of terms, we're going to end up with 9x plus 6y equals 18. We're going to end up with 10x plus 6y equals 22. And we're going to label them equation 3 and equation 4. Now, for our instructions, we're going to, watching for negative numbers. It doesn't matter if you end up with negative numbers, it just makes life a little bit more challenging. We're actually going to do, we are going to have equation 4 minus equation 3. And I'll write that up at the top. So we end up with x, the 6's cancel out, equals 4. Okay, we then do what we've done with all the other ones and substitute it into one of the equations. Now I'm going to use it in one of the original equations, so we're going to sub x equals 4 into equation 1, so that we end up with 3 bracket 4 plus 2y equals 6, 12 plus 2y equals 6, 2y equals negative 6, because we've taken the 12, which is positive, this to the other side and made it a takeaway. Therefore, y is equal to negative 3, because we have divided both sides by 2. So our solution would be 4, negative 3.